Hello students, today's video is on complex numbers. I'm going to discuss with you the cube roots of unity, its properties and applications along with previous year questions. So cube root of unity, z is equal to 1 to the power 1 by 3, then cubing both the sides, we get z cube is equal to 1 or z cube minus 1 is equal to 0. Using the identity a cube minus b cube is equal to a minus b into a square plus b square plus ab equal to 0. So we get z minus 1 into z square plus z plus 1 equal to 0. From here either z is equal to 1 or from here using the quadratic equation, roots of quadratic equations are minus b plus minus root of b square minus 4ac upon 2a. Like here, if we compare this with this equation, ax square plus bx plus c equal to 0. So here a is equal to 1, b is equal to 1, c is equal to 1. So x equal to minus b plus minus root of b square minus 4ac upon 2a. On further solving, I get this, which is equal to minus 1 plus minus 1 plus minus iota root 3 upon 2. So these are my roots. So one root is z is equal to 1 and these are two roots. One of them is known as omega, another is omega square. That means omega is minus 1 plus minus iota root. If you take omega as plus iota root 3 by 2 minus 1 plus iota, then omega square is minus 1 minus iota root 3 by 2. You can interchange both because both are square of each other. If I square this, I get omega square, and if I square this, I get omega. So both are square of each other, and whenever we get imaginary roots, they always occur in pair. Both are conjugate of each other. So we can either take omega as minus 1 by 2 plus iota root 3 by 2, or we can also take this as minus 1 by 2 minus iota root 3 by 2, or you can write this as omega square. If I square this, I get this term. If I square this, I get this term. Both are square of each other. Now the properties on omega are the sum of these three roots. That means if I add these three roots, that is 1 plus omega square, 1 minus 1 by 2 plus iota root 3 by 2 minus 1 by 2 minus iota root 3 by 2. What I get? 1 minus 1, my answer is 0. So sum of cube root of unity is 0 written here. Similarly, if we have to find the product, then product is here. That is 1 into omega square, 1 into minus 1 by 2 plus iota root 3 by 2 minus 1 by 2 minus iota root 3 by 2 is, if I use identity a minus b into a plus b is equal to a square minus b square, and hence I get 1. So the product is 1 and the sum is 0. From this property, what else I can conclude? That if 1 plus omega square is 0, then omega plus omega square is minus 1. Similarly, 1 plus omega, if I take this omega square to left hand side, then 1 plus omega can be replaced by minus omega square, and 1 plus omega square, if I take this omega to left hand side, can be replaced by minus of omega. So we use these results, and from this, that the product is 1. What I get, if omega cube is 1, or 1 into omega square is omega cube. So omega square can be replaced by 1 by omega or vice versa, or omega can be replaced, if I take this omega square to left hand side, can be replaced by 1 by omega square. So these are few results on sum and product. But what else we get? If cube root of 1 are 1 omega and omega square, then what is written here? That the cube root of minus 1 are minus 1 minus omega and minus omega square. So cube root of minus 1 are minus 1 minus omega and minus of omega square, right? What else we get while solving this? We get this equation that z square plus z plus 1 equals 0, and after solving this quadratic equation we obtain these two as our roots. This is one is omega, another is omega square. So whenever we get this type of equation, we should always remember that our roots are omega and omega square. But whenever we get this type of equation, then after solving this quadratic, we get minus omega and minus omega square as our root. If omega was minus 1 by 2 plus iota root 3 by 2, then minus omega was 1 by 2 minus iota root 3 by 2. If we obtained in my previous equation omega square as minus 1 by 2 minus iota root 3 by 2, then minus omega square comes out to be 1 by 2. Just multiply this throughout by minus sign plus iota root 3 by 2. So this is what minus omega, and this is minus omega square. Or we should also learn this, that instead of this above equation, if I get this, that z plus 1 by z is equal to minus 1, after taking LCM we obtain this. Again, our conclusion is that this quadratic will give us roots omega and omega square. Same here, if instead of this equation, if z plus 1 by z is equal to 1 is written, that means after taking LCM, z square minus z plus 1, this will become this. We should conclude that our roots are minus omega and minus omega square. So root of this quadratic equation, z square plus z plus 1 is equal to omega and omega square. Similarly, roots of this equation is again omega and omega square. If roots of this equation is minus omega and minus omega square, then the roots of this equation is minus omega and minus omega square. Now, here are the application. One more result. If omega cube is 1, if omega cube is 1, so whatsoever we get in the power, we have to divide it by 3, and the answer depends on remainder. That means if I have to find the value of omega to the power 256, if I divide this by 3, my remainder is here 1. So how I can write this 256 as 3 into 85 plus 1 omega cube. So omega cube is 1. So this becomes 1 to the power 85. So my answer is omega. So I just directly replace this omega to the power 256 by omega. Whatever we get the remainder, we just put it into the power. So value of omega to the power 256 is omega. Now if I get omega to the power 515, and if I divide this 515 by 3, my remainder is here 2. So my answer is omega square. And if the number is divisible by 3, then answer is 1. Now here is the application. If omega is an imaginary cube root of unity, then the value of sine omega to the power 10 plus omega to the power 23 into pi minus pi by 5 is. So sine omega 10 plus omega 23 into pi minus pi by 4. Omega 10, if I divide this by 3, my remainder is 1. So omega, if I divide 23 by 3, my remainder is omega square. And using the property that omega plus omega square is minus 1, so this comes out to be sine minus pi by 4, which is sine of minus 5 pi by 4. And as we know that sine of minus theta is minus sine theta, so this comes out to be minus sine 5 pi by 4, which is minus sign pi plus pi by 4 is second quadrant. So this is minus of minus sign pi by 4. So minus of minus 1 by root 2. So my answer is plus 1 by root 2. So the correct option is option C. Next application is here. As I already told you, alpha, beta are the roots of this quadratic equation. So there is no need to solve. You should know that the roots are, if we get this type of equation, then my roots are minus omega and minus omega square. So one of the root is alpha, another root is beta. And what I have to find the value of alpha to the power 2009 plus beta to the power 2009. That means minus omega to the power 2009 and minus omega square to the power 2009. And if I divide this 2009 by 3, I get remainder 2. So this comes out to be minus 1 to the power, odd power is minus, and after dividing this by 3, my remainder is 2. Same here, if I divide this minus 1 odd power is minus, but here what I do, I just replace this by this. I take 2009 within bracket and 2 outside the bracket. And as we know that on dividing 2009 by 3, we get 2 as remainder. So this is minus of omega square, this is minus 1, and this comes out to be leaving remainder 2. So this is omega square and whole to the power 2. So instead of multiplying and then dividing it by 3, as I already done this, so just interchange these two and put remainder here. Now I have just reduced the calculation. So this is minus omega square and minus omega to the power 4, which is again minus, and this is what, omega. So my answer is, this is what, omega square plus omega. And omega square plus omega, as sum of the roots cube root of unity is 0, so omega square plus omega is minus 1. So this comes out to be plus 1, and my correct option is here, plus 1. Now what next is, now look, in this question, if the cube roots of unity are 1 omega omega square, then the roots of the equation x minus 1 whole cube plus 8 equal to 0 are, this was asked on 2005. X minus 1 whole cube plus 8 is equal to 0. X minus 1 whole cube is equal to minus 8. We can write x minus 1 whole cube, and this minus 8 can be written as minus 1 into 8. Now just take cube root of both the sides. So left hand side become x minus 1, and on RHS I get minus 1 into 8 to the power 1 by 3. And as I already told you that cube root of minus 1 are minus 1, minus omega and minus omega square. So I can just write this as 3 roots of minus 1, minus omega and minus omega square, and the cube root of 2, real root is 2, 2 and 2. So from here I get x minus 1 is equal to minus 2. Further solving I get x equal to minus 2 plus 1, that is minus 1. From here I get x minus 1 is equal to minus 2 omega. On further solving I get x equal to 1 minus 2 omega. And from here I get x minus 1 is equal to minus 2 omega square, which is x equal to 1 minus 2 omega square. So these are my 3 roots, and my correct option is here, option 3. Now, alpha, beta, gamma are the roots of this cubic equation, where omega is the cube root of unity. Now, this is x cube minus 3x square plus 3x plus 7. And if I add and subtract 1 here, so I can easily reduce this to an identity. This is subtracting 1 and this is what I get adding 1. Now this become my identity, which is equivalent to x minus 1 whole cube. That is x cube minus 3x square into 1 plus 3x into minus 1 whole square and minus 1 whole cube. On further solving, this is what, and this is my previous question where I have already get minus 1, 1 minus 2 omega and 1 minus 2 omega as my roots. So from here my three roots are, which are here, alpha is minus 1, beta is here 1 minus 2 omega and 1 minus 2 omega square. Now I just have to substitute alpha, beta, gamma, values of alpha, beta, gamma here, alpha minus 1 upon beta minus 1 plus beta minus 1 upon gamma minus 1 plus gamma minus 1 upon alpha minus 1. So I have to just put these value here. After substituting alpha as minus 1, beta as 1 minus 2 omega minus 1 here. Here I put 1 minus 2 omega minus 1, 1 minus 2 omega square minus 1. Here I put 1 minus 2 omega square minus 1, 1 minus 1, minus 1. On further solving, I get, these all 1 cancel out with each other, minus 2 upon minus 2 omega minus 2 omega upon minus 2 omega square. Here I get minus 2 omega square upon minus 2. On further solving, I get so this comes out to be 1 by omega. This is again 1 by omega and this is omega square. Now if I replace this omega square by 1 by omega, as we have already done, that product of cube root of unity is 1. So from there we get omega square is equal to 1 by omega. So in this case my answer is 3 by omega. So that is my A option. But if you replace this 1 by omega square, so you can also write this as 3 omega square. So you may get only one correct option there, but here we have two options. So you may get 3 omega square as one of your option. So either answer is 3 by omega or answer is 3 omega square. Now if omega is cube root of unity, and this is written here that 1 plus omega to the power 7 is a plus b omega, and we have to find a comma b ordered pair equals to. So using the property that 1 plus omega is equal to minus omega square, I just replace this 1 plus omega by omega square. On further solving, I get this as minus omega 14, and if we divide this power by 3, we get 3 as my remainder. So this is minus omega square, and as we know that 1 plus omega is minus omega square because sum of the roots of unity is 0. So 1 plus omega, we can replace this minus omega square by 1 plus omega, and on comparing the coefficients, we get a is equal to 1 and b is equal to 1. So my ordered pair is 1 comma 1. So my correct option is here, fourth option, that is 1 1. Well, look, again we get this type of equation that z square plus z plus 1 is equal to 0, where z is a complex number, and we know that if this equation is given to us, so there is no need to solve. We just directly conclude that one of the root is omega and another root is omega square. So Here I am just substituting z as omega. We can just check by putting omega and we get same answer on omega square. So just I am checking on omega. I just put here z as omega, omega. Here I put to omega, then we get omega square, and here I get omega square. So just replace the z by omega in above equation, that is 1 upon 1, 1 plus 1 upon omega whole square, omega square upon 1 by omega square, omega cube upon 1 by omega cube. So the above equation is this, z plus 1 by z whole square, then z square plus 1 by z square whole square, then z cube by 1 by z cube whole square till z to the power 6. That means 3 more terms we have, that is z4 plus 1 by z4 to the power square 2, z5 plus 1 by z5 to the power 2, and z6 plus 1 by z6 to the power 6. Now I just substituted omega here, here and here. Now I'm substituting values of z as omega in these 3 terms also. So from here I get omega 4, 1 by omega 4 whole square, omega 5 plus 1 by omega 5 whole square, omega 6 plus 1 by omega 6 whole square. So from these first 3 bracket, I just replace this 1 by omega by this 1 by omega square. So this is omega plus omega square whole square. Again here using the property, I just replace this omega 1 by omega square by omega. So again this. And as we know that omega cube is 1, so I just replace this by 1 and this by 1. Now this becomes 1 plus 1 whole square. Now this pattern is repeating in further these 3 brackets also. So we just get these kind of triplet again. So instead of solving those, we can directly conclude this comes out to be this first 3. I'm just solving the first 3 brackets. This is minus 1 whole square. Again this is minus 1 whole square, and this is 2 square. Now if I solve this, so my fourth bracket comes out to the pattern of this triplet is repeating in further 3 brackets also, but I'm just showing you that omega 4 is omega, and 1, this is 1 by omega. Omega to the power 5, if I divide this by this, comes out to be remainder 3, 2, and here I get 1 by omega square whole square plus another 6 bracket, that is omega 6 is a multiple of 3, so my answer is here 1 plus 1 whole square. So you can easily see that the pattern is repeating. This is again minus 1 whole square, minus 1 whole square, and 2 square. So my answer is 1 plus 4. Again by solving this I get 1 plus 1 plus 4. There's no need to solve. We can just find the answer 6 and multiply this by 2. So my answer is 12. So in this case my answer is 12. Now this question was asked on 8 January 2020 JEE exam. Now alpha is given to us here minus 1 plus iota root 3 by 2, that is omega. Further, A is 1 plus alpha sigma, K is from 0 to 100, alpha to the power 2k. And another given condition is B is sigma K is from 0 to 100, alpha to the power 3k. So these 3 equations are given to us, and on opening the summation of equation 2 sigma here, I just put A is equal to, I just replace alpha by omega here because alpha is omega given to us. So this comes out to be 1 plus omega. If I replace this alpha by omega, so this comes out to be 1 plus omega. And on opening this sigma, if I put K0, my first term is 1. If I put K1, so my second term is omega square. If I put K2, my third term is omega to the power 4. Similarly, if I put K100, my last term would be omega to the power 200. And we can see that this is what GP, geometric progression, where first term is here, that A is here 1, and common ratio is here omega square. And sum of GP is 1A 1 minus Rn upon 1 minus R. So here I am using this formula. So this is 1 plus omega, and here using the formula of sum of GP, A is 1 minus R is here omega square, and number of terms, since we put here 0 to 100, K is from 0 to 100, so number of term is here 101. So omega square to the power 101 upon 1 minus R, that is 1. So this is 1 plus omega, and this is 1 minus omega to the power 202 upon 1 minus omega square. And on dividing 202 by 3, we get remainder as 1. So we can check this. If I divide this 202 by 3, my remainder is here 1. So this is 1 plus omega, and this is 1 minus omega, and in numerator I get 1 minus omega square, 1 minus omega square. So my A comes out to be here 1. So in question we have to find A and B are the roots of the one of the following quadratic equation. So I obtain my A as 1. Now B, if I open this sigma, I get B. So alpha is omega, and we just vary K from 0 to 100. So my B is here K0, so my first term is here. Since B is sigma, K is from 0 to 100, alpha 3K. So by putting K0, I get 1. By putting K1, I get omega cube. By putting K2, I get omega 6. And then I get omega. By putting K3, I get 9. And by putting this, I get 300. And these are all multiple of 3. So each term will give us 1 as the answer. So I'm adding 101 times, since K is from 0 to 100. So B comes out to be 101. Now these are two roots, and I have to find the quadratic equation, and quadratic equation is x square minus sum of the root plus product. So here I get x square minus 101 plus 1x plus 101 into 1. So my answer is x square minus 102x plus 101 is equal to 0. So my correct option is here, option second, x square minus 102x plus 101 equal to 0. So this is all about cube root of unity. I'll be back with new video on complex number very soon. So please like and share it as much as you can, and subscribe my channel method wise. Thank you.